Hello and welcome to Maths with El Profelo. In this video, we're going to be doing some elementary number theory and talking about Fermat's little theorem, right? And recall that Fermat's little theorem states that if P is a prime number and A is an integer, then as long as P does not divide A, we have A to the P minus 1 is equivalent to 1 mod P. Right? Corollary to that deals with finding the inverses, and another corollary deals with finding what A to the P is, but we're not going to concern ourselves with that information at this moment. Okay, what we're going to do here is to find the least non-negative residue of 29 raised to the 202 modulo 13. Okay, so what do we have to do for these problems? Well, the first part is to make sure that 13 does not divide 29, right? Because for Fermat's little theorem, that has to be true, right? That we have to make sure that P does not divide A, right? And that's true, right? And we know that 13 is prime. So therefore, Fermat's little theorem can be applied. Okay. Then what do we have next? Okay. Well, based on Fermat's little theorem, 29 raised to the 12th power will be equivalent to 1 modulo 13. And the reason it will be equivalent to 1 modulo 13 is by Fermat's little theorem, right? Because I'm going to have that 29 raised to the 13 minus 1 is equivalent to 1 mod 13. So that's what I have, okay? Now, I'm going to write this to the side, and you can check it on your own. But 202 is equal to 12 times 16 plus 10. Why is that important to us? Well, that's important to us because we're working with 29 raised to the 202nd power, which can be written as 29 raised to the 12th power, all raised to the 16th power, times 29 raised to the 10th power. And that's going to be equivalent to 1 raised to the 16th power times 29 raised to the 10th power modulo 13. Right? And where did this come from? Well, we said that 29 to the 12th is equivalent to 1 modulo 13. So that means that this 29 to the 12th can be replaced with a 1. And then I still have this 29 to the 10th. So that's our first step. But now we've got 29 to the 10th mod 13, and we need to try and figure out this value. Okay. So a way that we can do that is the following, right? Is we can come over here and we can say, hey, you know what? Is there some power, right? Is there some power of, let's slide this over here. Is there some power of 29 that is going to have a remainder of 1 modulo 13? So I can type this into my calculator, 29 raised to the x power minus 1 over 13, and I'll be looking for integer solutions. So if I go to my table, right, I see that I have an integer solution when x is equal to 3. Okay, so what does that mean to us? What that means to us is that since 29 to the 3rd power has a remainder of 1 on division by 13, and 29 has a remainder of 3 on division by 13, then we can write 29 to the 10th as 29 to the third power raised to the third power times 29, and that's going to be equivalent to 1 raised to the third power times 3 modulo 13. Why is that? Well, this 29 to the third got replaced with the 1 based on 29 to the third being equivalent to 1 mod 13. And this 29 got replaced with a 3 based on 29 being congruent to 3 modulo 13. So what does that tell us then in the end? So therefore, 29 raised to the 202nd power is equivalent to 3 mod 13. And my answer to the least non-negative residue of 29 raised to the 202nd modulo 13, that answer is 3. Right? The 3 is that least non-negative residue. So that's how we can apply Fermat's little theorem and then further use our modular arithmetic to solve this seemingly complicated problem. Okay. In our next video, we'll cover practice problem 3. Thank you for spending time with us. This has been Maths with El Profe Lo.